progress. 4 uncertain. Perfect. All right. So where are we? What time? And all right. So about half an hour, 40 minutes, something like these. Join me. Join me to see. Join to see. Learn PCB design. 2 weeks. 2 weeks. Okay. Okay. So perfect. Well, we'll actually just do everyone. I never know. Like I never know. It's if what's this? Community. All right. Cool. Perfect. So we are back at these. And let's go back. Let's go to the dashboard and let's go back to the plan. So we're going to not latest plan, all session. PCB design, that's the one that we want to. Okay, yes. So we have a few sessions in progress. We have the software overview in progress. We have the layout and routing techniques in progress. Today I'm feeling like before. So what I did is I downloaded KiCad. Right? But I just have no idea how to use it. Okay, so this is KiCad. I have no idea how to use it. And so we can either, so we have here like a schematic editor, symbol editor, PCB editor, footprint editor, and stuff like these. So one of the things that I'm gonna do today is, I think I should just do a deep dive on the tool, to be honest. So I'm gonna try the following. I have KiCad open. We're gonna continue with this lesson. Okay, so we're gonna open this lesson and or this session, right? And essentially what I'll do is I'm gonna try to use the tool to learn about how to use the software, and you will see. So again, it's just to show that the whole point of openLesson is not to give you the content to learn, but it's to help you stay in a loop, right? So and we're now basically at this point here. So we're at what is the current understanding of PCB design software and its main functions in the layout process. So we have a few things to go through to complete this session. How do you think PCB software detects and prevents design rules violations? 3 design rules, trace width clearance, and explain how software might enforce them. So there's a bunch of things in here that we should go through. We talk about routing algorithms as well, okay? Then auto routing versus manual routing. So it seems like software is going to be able to do that. Then we have outlined the steps to set up and run a basic simulation. Okay, so we're going to get into simulation. That is also interesting. We have to check those things. Again, those things don't need to be checked necessarily in order. We'll get started with a question, which is, what's your current understanding of PCB design software? And then what I'll do for this session, though, is the following. I'm going to take this out. I'm going to minimize these. I am going to decouple the monitoring. So I have it here. So I have these here. And what I'm gonna do, because I need to what I'm trying to do is perfect. Yeah, again, I have these here. Perfect. I have the session. So what I'm gonna do is I am going to screen share these with the tool itself. I don't know if that's gonna work well with let me start the session. Starting the session now, and let me decouple these. So So I have these here now. I just have these here decoupled. Okay, so I'm not gonna. The thing is, I can't show everything at once. So I'm gonna keep these here somewhere. Um, and what I'll do, because I don't have enough screens to do everything, but essentially I have this component on a secondary screen so that I can read what is the thing. I can read the stuff that matters. And perfect, yes. And then I can kind of see whether I'm doing well in terms of the questions and whatnot. And I'm gonna have two things. I'm gonna have these here. So I'm gonna share screen right now. I'm sharing my screen number 1. So I'm sharing now this screen. You can see here it says recording screen, right? So it's recording now the screen. So essentially we're sending these to the monitoring system every now and then. We're actually sending screenshots of to help me understand, just to kind of like talk through the stuff. And what I'll do probably is I will open one of my favorite tools, which is Grok. So we'll do Grok on one side and we'll do KiCad on the other side, right? And we're gonna use these to learn while I'm being guided by the tutor, right? So here we're gonna have I have to work on this. There seems to be some like um, connectivity issues, but it's working well. So what is your current understanding of PCB design software and the main functions? So the way that I'm seeing these is, I guess the purpose of the software, the way that I understand that is basically to I think what's happening here is, or the whole process of, because I see a lot of tools, which is quite surprising. These calculator tools, drawing sheet editor. Like I would have expected only to have like a schematic editor, which is, I think that's just the abstract model. um so you see that maybe what I should do, what I should do, maybe I can, one thing, just for the sake of the stream. Okay, let me just for a second pause this, back to the I'll just I'm just what I'll do is, I think I need to have a setup. Right, that's the full session. So I need to actually have maybe a setup on OBS where I can add a secondary component. So you see, can I add here a capture scene media, next video. Oh, display. Okay, no, it's not that easy. Browser. A new browser. No, okay, that's actually, never mind. I'll figure it out. I'll do this for the next session. Okay, so I think there's a way that I can actually put a secondary widget on the screen so that you can see what I see in my other display. You know what I mean? Like you can see just the. So let me start the session again. Let me decouple the computer. I'm currently having two tasks. List the main functions of PCB design software and screen. List the main functions of PCB design software. So I'm having these questions, right? So list the main functions of PCB design software, exactly. So essentially, I'm having these here, and I want to, yeah. I mean, let's think about these. So I thought about the fact. First of all, I thought about the fact that it would just be something where you can. To be honest, the dumbest way that I imagined these was like that it would just basically be, a one editor kind of thing. But it seems like it's more, right? It's so I'm just looking at it, and essentially it's like you have a schematic editor. Um, so these tool here and these wait. What is schematic? I have to create a project. Okay, so these tool here and these tool here, it seems to be the only thing that I thought would be needed, right? No idea what the curve review is. No idea about this stuff, right? So essentially, I don't know what calculator says. Show tools for calculating resistance, current capacity. I mean, this is advanced advanced stuff resist is this is more for the simulation aspect of it, I think. Image converter, the schematic symbols. Okay, so I think this is maybe something for the you know, the markings and whatnot. But let's just open a file. I mean, that is, I think, the again, the question is, what is your current understanding of PCB software design software and its main functions in all the layout process? That's what I think it is, right? So um, it's essentially uh, it's essentially a tool that is going to take you from a schematic and an idea um, to sorry, I got another question now. Building on your mentions later, what are your primary functions? Yeah. So essentially it takes you from the schematic idea to something that is then ready to maybe, you know, produce and manufacture, right? I think that's the way that I understand. That's my current understanding of what the software does, and it probably has then tools in between to help you simulate, make sure that, you know, whatever you will send is actually something that can be manufactured, something that is actually going to work, and things like these. So the main functions of PCB design software are probably like these. It's probably like editors and simulation, some kind of validation type of thing. That's what I would assume. Okay, you've heard that, right? So essentially now what happened is Grok has told me, okay, you're done with question one, right? So this is done. Perfect. And now we're on to question two, which is, how do you think PCB software detects and prevents design rules violations during component placement and routing? What I'm gonna do is before jumping into this question, I want to play with this a little bit. So let me see what we have here. List the main functions. That is going to be marked as done. Building on your mention of a schematic editor. What are the primary functions? The layout portion, software function placement, trace routing, and layout. What are the primary functions of the PCB layout portion for component placement, trace routing, and function? Do you think PCB software detects and design rules? I mean, I think it does. I think to answer this question, I think that what it does is it kind of does some degree, some kind of like a static analysis. You know what I mean? So how does software detect and prevents design rule violation during component placement and routing? I think there's it's a bit like software, right? That's my way of thinking, is that it probably does some kind of static analysis or some kind of static analysis of your design, and it also does some simulations, which would be maybe like, you know, doing a few like runtimes and whatnot, and then these when these runtimes are happening, it's you know, it's simulating it, and it's actually checking if there's any failures or errors in the way that you've designed it. How do you think PCB? How do you think PCB design software? Yeah, I think that's the way it prevents design rule violations is static analysis. It's my guess, um, but we can see for ourselves, right? So let's see. What do we want to do? So we want to start a project. We're gonna call this test PCB. Okay, test PCB. Um, yeah, I guess whatever. So we start a project. Oh, okay, interesting. So would you want to go check for updates on startup? Yeah, it's okay, perfect. So we have right away like a PCB editor and a schematic editor. So we actually have these two, which basically is it kind of is the same thing that I thought about. Like it's what I assumed would be the main thing, right? So the main two elements would be a schematic and an actual PCB design. If I open the schematic, it opens just like that. Okay, so it opens the screen, which is like, what? And I want to do, you know, ideally, You know what I think it's pretty interesting, that it doesn't have it doesn't seem to have like a programmatic view or something. You know, Blender does this really well. You can actually with Blender just run some sort of like Python script, and it actually renders then it does the work for you, right? Instead of just having to figure out the interface, because essentially symbol editor, symbol library. So here we have on this side, it seems like components, wires, draw rule area. Is this maybe an area where I can then define rules or something attached to this area? Okay. Okay, interesting. Can I move this area around? Can I delete this area? Yeah. Let's go back to the tutor. So list the key functions the PCB layout software performs. Okay, well, let's pick one question. Sorry. So list the main functions offered in the layout process, such as those related to placement, component placement, trace routing, and layer management. So let's actually talk to Grok. So, hey Grok, remove the costume. How do you know? So do you know how that works? No, not Key, the Python-based library. What's the name? Did I just minimize? iCAD. Okay, wait. What did I say? No, I mean KiCad. I mean the PCB design software. Oh, sorry. It's like that. So I'll go back to, okay, I let me see. I just want to go straight into what routing algorithm. Outline the steps to set up basic. So what I think one thing that I don't like is the way this session seems to be organized too much around the theory of these. I want to get my hands a bit more dirty. So I'm going to do the following. I'm going to stop the screen. I'm going to go back to the, so I'm back here. I'm going to pause the session. Because and this is the great thing about the flexibility of the system. I pause the session now. I'm going to close the session. Okay. So I want to go back. I just maybe that should actually go back to the I want to go back to the PCB design to the plot. And what I want to do, is software overview. Yeah, because that's software review. So I actually want to have a session, hands-on project. Let's go with hands-on project. So apply all concepts design layout in small PCB projects such as a LED basic circuit. So we'll start with this one. I wanted to do the project in here, so I kind of wanted to just start right away with these, and then we'll go back. Then we'll go back to the other session. I think that is that is something that kind of makes sense. So we'll actually do the hands-on, and I'm gonna move that again aside, just because I want to explore the tool like these. It kind of makes more sense from my perspective. That's how we speed things up a bit. We have these started. The session starts with a preparation question, then create a new project and draw a simple schematic. Okay, cool. Let's do these. So just to show you the session layout, right? So let's get started. The first is the difference between a schematic and a PCB layout. Let's go. Let's start the session. So the difference between a schematic and a PCB layout is basically that the schematic is more the conceptual part. So in the schematic, you don't care about the physical laying or the physical organization in a board. You just care about the components and how they're connected, how they need to be connected, the concept, right? So we need this component connected to that component. We need this. It's just a schematic. It's just a schema of what you want to build. And what are the assumptions that you're making before starting this? I think the assumptions you're making is that you just have all the space available, you just have no physical constraints. You're just basically, it's like a blank canvas, right? You can essentially uh, just do whatever you want, and I think that's it basically. So in the PCB layout, you're going to be more constrained by already sort of the physical structure of everything. Um, so I think that's that's about it. Let's just look at KiCad. I think what I'll do is I'll mark this one as complete. And okay, wait a second. You mentioned assuming all the space and no physical constraints, like a blank canvas. What specific manufacturing constraints, like minimum trace width, clearance rules, or component spacing, should be actually considered even before? I don't think that really matters for the schematics. Does it matter for this? Does this matter for the schematic layout? Um, do any physical constraints matter in PCB design when you are just at the schematic stage? I'll have to. No, not directly. Schematic stage are mainly different electrical connections, and yeah, okay, perfect. Um, okay, that's right. We move on to the next one, which is create a new project in your PCB software and draw the schematic for a simple circuit like an LED with a current limiting resistor. Okay, so we'll do that. Okay, let's see if we can do that. Okay, let's do these. So we're actually here. I'm gonna mark these questions as done, uh, and we will actually do the follow are here. Put these here my screen gonna be um good test. At the same time, testing the tool. Perfect. Because I have the feeling one thing, I'm not so sure it's actually, yeah, anyway, a few things to recheck, but it's all good. So we'll try to do an LED schematic. I mean, an LED schematic should be simple, right? It should just be like, does this have an LED component or something, something like that's the first thing even. So we've got no connect flags, hierarchical sheets, play sheets, whatever. Here, what is these? Symbol editor, symbol library browser. Okay, so those are components. I go for like an LED. An LED driver and an LED. Okay, and then there's tons of like different standards or whatever that is. Integrated controller, LED. Okay, so what is that even? I will ask. I'm gonna ask Grok. So what's that? What's that here? Yes, I created a new. So I created a new project. So you see, you've heard the sound, right? So essentially, what the system is detected is that I've created a new project and that I'm working on the LED circuit. It flagged it as done. Okay, and now I'm in the next one where I have to design and build the components and so you have component footprints and okay. Well, this is sort of the next step. Some one is basically um, but I know I'm noticing that when I'm separating the view and sharing my screen, it actually does have a few. But yeah, let's just go. Let's go to Grok. Because essentially, I think that is. I'm not so sure if this is really then the schematic that. And if I do these, like, do I need to like? Can I just like select these or what's that? Add symbol to schematic. Okay, I can actually add the symbol to this. Doesn't added the symbol. Okay, let's try again. LED. No, symbol editor. No, I'm not the symbol editor, the library and footprint editor. Oh boy. Oh boy, what's happening? Ecat. Ecat, where did you go? Um Ecat quit unexpectedly. Software for this is crazy, bro. Okay, anyway, so let's just open the schematic again. Um it's potentially embarrassing. It's okay. It's okay, don't worry. We all make mistakes. Loading. So this is the symbol library. And I updates window. That's fine. So I'm looking for an LED and I can pick whatever I want from here. Okay. Um cool. So the sounds you're hearing is basically the monitoring progress moving me forward as I develop uh pin numbers. Okay, and I can just now what can I do? I can add these now to the schematic. Show data sheet. Let's just do these ones. But it didn't add this to the schematic. Is this software that broken? Schematic hierarchy, root page. How to add a summarize the schematic work so far? Yeah, I mean, how I even add these? How do I add a LED component in KiCad's schematic editor? So double click on the schematic file to enter E schema. Method A, toolbar button most common. In the right hand toolbar, click a place symbol icon. It looks like an AND gate or a small component box, usually second or third in the top. A, place symbol. Choose a symbol. Okay. Okay, so that actually triggers these already. Choose symbol. LED. Okay, so now we have a LED. Oh, cool. Now I have it here. Now I have a LED. I have a LED, guys. I have a LED. I have a LED. Perfect. And what is these now? Um, do I need to add a power source or something? Power. So do I need to add a power source? Battery? Uh, what am I doing? Okay, so that's power. And this is then what is these? So this is highlight nets. No. And now do I just connect? Oh. What is this? Like have I connected these things now or what is this? It looks like, right? Okay, I need to get used to the controls here. So I have the LED. What have I done now? Grog. Oops, I stopped sharing. um, so what have I designed now? So you see, the whole point is, what I'm having basically the tutor guiding me through like what I should be looking at, but I am the one responsible for, right? So we've so far talked about the differences between schematic and whatnot. We've actually designed, or we created a new project, and we're now designing the LED thing. And yeah, so that's basically where we are right now. So you've designed a very basic LED indicator circuit, but one that's incomplete. Yes, there's an LED symbol. There's an anode, the anode positive side connected via green wire. The cathode negative side of light bar connected to nothing visible, implying ground or whatever. In short, the to light up a light directly from a 15 volt 15 volt supply, probably assuming the other end goes to ground. Why is this a problem? LEDs are current control devices with very low forward voltage drop. So red, yellow, green LEDs, blue, so they behave like diodes. Once voltage exceeds, they choose exponentially without current limiting. Yeah, that's one of the miscommon beginner mistakes. Yeah, sure. So how to fix these? Add a current limiting resistor. So yes, hotkey R, place symbol between. Can I just click R? Okay. Yes, I'm gonna wrap it up now here. Okay, so yeah, we'll basically do a very basic thing where there's gonna have like some power source, an LED, a resistor, and then we'll just like, yeah, we'll just do that very simple. Okay. Okay, I'm gonna back to the session. I will actually pause the session and are basically almost at a point where you need to actually. Okay, so these is hope for this project was just okay. Then once I'm done, generate the Gerber files, the real files, and needed for to order the piece. Piece about electrical. Oh, does KiCad actually generate the from this? Probably just twice at least. Okay. It transfers connectivity. Manual layout in PCB new. Perfect. Yeah. So you see the whole premise of open lesson that you need. So you're gonna have some minimal guidance around what you're doing. What questions should you be focusing on, or can you be focusing on? And it's basically monitoring the way you're thinking, the way you're looking at these, you're looking at the screen, etc. Right? But it's important because there's so many different ways to learn these. Like you wouldn't go like you know it might seem very basic what I'm doing, but the whole point is, if you've never done something like you wouldn't actually you wouldn't actually be able to even get started. And you'd have to have very sort of step-by-step guide on like, yes, let's this and let's connect this and that. You have to think through stuff. That's how you're gonna learn. That's how you're gonna learn the most. What do those even symbols mean? Stuff like this. Anyway, we'll save this project, this amazing project, and I'm gonna I'm gonna ask Yatsin how. I'm gonna ask Yatsin how I'm doing. How's he called this? Oh no, not Jack. No. Um. I forgot his handle. It's fine. I'm gonna ask Yasin how am I doing. It's a joke, obviously. Okay, cool, perfect. Yes, so we have the session paused now. Um, I did notice that actually Grok was a little eager to flag some of the items green, and to be honest, I wouldn't say we haven't really considered the footprints connections should account for manufacturer constraints. So we haven't actually discussed this stuff. I think it was a bit eager in marking that, but I think that's something we can adjust with it. So that's why I'm testing this, right? Because I want to make sure that the way that the monitoring is going through, that actually it makes sense, right? That it's actually, and this is the piece that it's complicated. The piece of the piece here is that the LLM at the core of monitoring is likely not ready yet, right? As Karpathy said, the technology to like fully understand what's going on and really sort of evaluate the quality of what you're doing kind of not perfectly there in a generic way, but we're trying to kind of find a way to refine this, flow. The whole point of openLesson is to have that harness around, to have that concept of like, this is your progress, these are the guiding tasks, right? You speak out loud, you share your screen, you upload images, you talk, you draw, you do stuff like that in here, and the system sort of like guides you through the process. But it's ultimately you that have to actually speak out loud and use the tools that you have at hand, um, you know, to actually get started. I think a few ideas that come to mind as like nice things to add, nice feature requests for myself. Um, suggest toolings, suggest tooling, suggest material. But maybe, I mean, that is already here. So practice and theory. I mean, that would be basically something that I could go in here and then use the practice, um, to get started. But maybe some more guidance in. I think that's pretty okay. I think it's okay. It's just a matter of the fact that maybe we can just share the screen without popping up. You know what I mean? Have the share screen directly, even if we're not like having the pop-up window. And Because to be honest, maybe we can get rid of the pop-up because of that. I think that makes because the pop-up window feature is a little clunky, and it doesn't really have. Oh well, no, it has. It actually has. It actually makes a case in which you want to separate the two. It's all good. But I want to add. I definitely want to add screen share. Um, Screen share here somewhere. Maybe in data input, like screen share in data, and I think that actually could work as well. I'm gonna add this as a screen share here, a screen share, and then I also want to have like an image upload, something like that. Cool. Guys, see you later. I'm gonna do another stream probably later. Keep updating everyone. See you later.